Good morning to everyone. My name is Gonski. My group name is MWS, and I'm going to present my title, which entitled Develop an Image Fusion Technique for Enhancements of Low Quality Image.
Okay.
So, what is image fusion? Image fusion is a process of integrating data from two images to form a single highly informative image.
There are three basic categories of fusion. Firstly is the multi-view fusion, means that images are taken from different conditions, such as the first input image, the foreground is clear, but the second image, the foreground is blurred. Another type is multi-focus fusion. Multi-focus fusion means that the images are taken at different focus length. And lastly is the multimodal fusion. Multimodal fusion means that the images are taken from different sources, maybe from infrared sensor, maybe from vision camera. For my project, firstly I will input two vision image or one vision image, and another is the grayscale image. That means it's panchromatic image. Then we will run through the simulation process using MATLAB software. Then I will do on the image enhancement to that means we also mean the image fusion, and lastly is the face detection. Problem statement. Loud and noisy image is caused by some factor. Firstly, different weather, like sometimes rainy day we cannot really see on the car plate, read the car plate number. Next is the different focus length. That means you like using DXLR, sometimes we focus only the foreground, but the background is blurred. The last is the different resolution of the capturing device. This means like infrared camera we can see the smoke, the house behind the smoke, but for vision camera we cannot do that. We only can see until the smoke. So my objective is, firstly my objective is to removing noise from images. Secondly, making images more visually appealing, and lastly is for face detection. Now there are two types of method I'm going to apply for image fusion. Firstly is discrete Wheeler transform, which also means DWT. Now I'm going to explain what is DWT. Firstly, the image must be the same size. Then next it will decompose the image into the wavelet domain. In wavelet domain we have LL band, which also means low band, LH band, low high band, high low band, HL band, and lastly the high band. We only continue to decompose on the LL band. Why? Because LL band contains the information, while HH band contains the noise with the high frequency. So we only interested to decompose on the low frequency with the detail of the information. Lastly, only the multi-skew coefficient from the two images, which means the two details from the two images after went to decomposition level will be fused together. Then lastly, it will if went to IDWT, inverse discrete Wheeler transform, to convert back into the fused image. This is the last result that I'm going to get. The next method is the IHS, intensity hue saturation. For this part, the first input image must be one panchromatic image. What is panchromatic image? Panchromatic image is a grayscale image but with higher spatial resolution. Another one input is the MS image. What is MS image? MS image is a multi-spectral image. It's an RGB image but with lower spatial resolution. Then it will, from the MS image, it will decompose from RGB to IHS domain. What is I component? I is the brightness and the brightness to the darkness. For the hue, HUE, the hue is the dominant wavelength because different color got different wavelength. And S, saturation. Saturation is the colorfulness, but it's not dilute with white. That means the pure. Then the I component will be replaced from the I component from the panchromatic image, which means the I component from the MS will be replaced from the I from the panchromatic image. Then lastly, I will fuse I will show a better view. This is the flow of the IHS process. That means the I from the MS image will be replaced by the I from the panchromatic image. Then only we convert back from IHS domain to RGB domain.
as you can, here's some comparison. Maybe you do understand what is saturation. Saturation, this is the saturation part, the pure, but it's not dilute with white. So my my result is to get like the first input image, the foreground is clear, but the second input image, the background is clear. So when I fuse, I only extract the detail to fuse together and get a better enhanced image. Now I only apply phase detection. For IHS fusion, the one input must be the MS image with the high spectra but low spatial resolution. Another is the PAN image with a higher spatial resolution. But it's a grayscale image, you don't have color. So it will get a better before and after. So now I'm going to demo on the GUI. I'm going to present using MATLAB software. Firstly, there are auto selection and manual selection. For example, if I choose the auto selection. This means that the input image I already set for the user. This is for demo only. So firstly, I will click like I choose IHS fusion, let's say. Then I click medical one. Then I load image one. For IHS fusion, one of the image must be panchromatic, and another is the MS image. Then only I click fuse image. As you can see, why the color have been improved, because before I go into image fusion, I got apply histogram stretching. What is histogram stretching? The objective of histogram stretching is to increase the image contrast. It means it works by stretching the intensity level to the desired range. For some analysis, you can click image one to see the original and after apply histogram stretching. That means the color have been stretched, balanced equally. So another part is for manual selection. Let's say now for manual selection, we choose the image from the folder in my laptop for experiment. So when I click load image one, you can choose from these three folder only. If I choose from this folder, it will be no file because I already set the format. So you only can choose from these three folder. Like I'm going to choose satellite. I'm going to import image one, and for the second image, I click load image two, and I click back the same image but with different focal lengths. The first image, the foreground is clear, but the second image, the foreground is blurred. So now I'm going to apply fuse image. The image has become with higher resolution. So I'm going to apply phase detection. Yeah, this is the result. But now I'm going to compare why I have to enhance for feature attraction later like phase detection. If I didn't enhance it like for these two images, this is just an experiment. Like these two, I haven't fused with different blurring part. So when I click phase detection, it cannot detect. This is the purpose of applying image fusion. So if I load image one with different focus length, now the focus is different for foreground and background. Then I click fuse image. Then now I apply phase detection. It can detect already. There is no message board displaying no face detected. So the next part is I'm going to talk about the above, the auto, this part and this part, auto and manual, is for two input image. But let's say if the customer only bring one input image for us. So I'm going to do some image enhancement on it. For the one input source, we only can choose from this crop folder. If we choose from medical, there will be no file. Because for this crop folder, only one input source. There's no two input source already. So let's say I'm going to do testing on this PCB board. So I click on duplicate and enhance. Then I only fuse. At this part, for the grayscale part, I apply the Lucy Richardson. Lucy Richardson is a convolution process between the input image with a point spread function, which also means PSF. And in my project, the PSF I'm going to use is the Gaussian filter. So that means I apply noise to the image first, then only I do the convolution back. So as you can see, from the original image, the source cannot be seen, hardly to be seen. But after applying the image fusion, the software is more easily to be read. I'm going to do testing on what happened is on rainy there. So like this the image taken from raining there. So I apply duplicate and enhance, then only fill the image. The car plate number can be easily seen. Sometimes the user only interested in the ROI region, which means region of interest. So I have another option from here, crop. When I click the crop, the bottom one will be display crop image. So when I crop it, then I choose the folder. It's the same folder from one source folder, which means the crop folder. Let's say I use back this image, then I click, right click, I choose crop image. Then only I duplicate and enhance, then I fuse image. The image has been enhanced already. Now we're going to do some comparison. Since we have DWT and IHS, so what's the difference? For the comparison, you can click the auto selection and click the comparison radio button. So let's say I'm going to compare this medical one. So I click load image one. When I click, the upper part is the DWT fusion and the lower part is the IHS fusion. Then I click fuse image. As you can see, different focus length only work for DWT because it will extract the detail of the two information and then fuse together. But it do not really work on IHS because IHS is just replaced by the I component from the panchromatic image. As you can see, the foreground is quite blurred, didn't enhance any. And the processing time, I make some comparison. As you can see, DWT processed a longer time, but on the other hand, IHS process a lesser time. So let's say if I have one pen image and one MS image, because these two from vision camera, but with different focal length. Now I compare with one pen image and one MS image. So now this MS image and this pen image. So now I click fuse image. I want to compare. As you can see, DWT fusion still can fuse the two images with the detail inside, but the color have been lost. But on the other hand, IHS fusion able to retain the original color. But the process time is still faster than IHS process. The original color loss. There's a save as button is for like, let's say I want to save the enhanced image. So I just click save as and save in this folder. Any folder you like, Q. Then when you open the folder, it already saved inside, yes. The save as folder, this. Yeah, okay. So that's all for my presentation.
That's all from the okay, good. Thank you. So, where you get all these images from?
From internet, but I do some.
Okay. Oh, you did some Photoshop.
There's some different one. I use MATLAB instead of OpenCV. Because for MATLAB, if I have to input image, I just put I equal to IM rate. But for OpenCV, we first have to declare the library. Then next we have to declare the variable, either floating point, character, or integer. Then lastly, we only input the image.
Okay.
That's why, because MATLAB is easier for the first learner.
Okay. So you get images from online and then you did some modification.
Yes.
And then you fuse it together.
Yes. I just want to prove that this fusion works. Yeah.
Did you build this GUI by yourself?
Yes.
Every single part you built by yourself?
Yes. Because my lecturer has
ask you to do
encourage us to do.
Alright. How about the algorithms?
For the fixed detection algorithm, I use Weiler-Jones.
Okay.
It's a hard-based light feature that turns into a powerful classifier. That means it will detect the skew face, then it will continue to do iteration. Like for human face, we got 2 eye, 1 nose. Then we'll continue on the highlight feature based on.
Okay, alright.
And for the IHS algorithm, that's actually, it's just like, this is the formula for convert RGB to IHS.
Okay.
And this to convert that IHS to RGB domain, that's another formula. This for IHS. For the wavelet, firstly I will break into low, high band. That means I can show the.
Do you write all this or you modify?
I got reference some.
Reference and then.
Now I only do on my own system.
Okay.
So this the DWT. I said earlier, got low band, low high. I will extract first.
Okay.
That I only do fusion on them.
Okay.
For the IHS components, this is the formula to display the IHS component. This is the IHS component. This formula you can see from my code. This to display. Opting IHS. This fixed already because from reference location.
Okay, understand. No problem. Anything you can ask? Good job. So, is this a new thing or is it something you think of or someone else?
Actually, there is some design already designed using image fusion, but they didn't really compare on both method, like compare between both method. They only applied wavelet, so they are doing research on wavelet only. So for my research, I just want to do comparison. This is the comparison plus on the processing time. Because IHS is a faster processing because it just replaces the I component. Unlike wavelet, we have to decompose into different levels. They only we fuse together the multi-core fusion.
So your research, you found this out?
Yeah, currently I just compare on the time.
Okay.
About the error to noise signal to error ratio, I haven't developed that. But my project is more on visual artists that directly look on the comparison. That means I just compare directly look from visual art. Sometimes they ask, what is the difference between your project and the Photoshop? Since they also get enhancement, but you have to know that Photoshop don't have the threshold value we cannot set.
Okay.
But if using MATLAB, if you're not satisfied, I can help you to program the threshold value. Because for Photoshop you just click dilation, evolution, but we cannot set anything inside. But for MATLAB, we still can verify the program. That's the benefit of MATLAB.
Photoshop cannot do that?
Photoshop is just like, you cannot click the threshold, you just click threshold, RGB to grayscale, you cannot set anything numerical inside. Because for MATLAB, I still can modify in the editor. So it's very useful for later like topic detection, face recognition. Photoscape will have face detection on this feature.
So you read out these papers?
Currently I'm just doing research on these two methods. There's still like PCF, principal component, but I haven't developed that.